anything?
Yeah.
Have you ever worked on multicast or no?
May I proceed, or Narcissus is saying something?
Narcis, I am not able to hear you if you are saying something. Can you repeat again, please? Okay, maybe Shashank,
Yes.
you can.
Yes, you have said multicast when you send a packet and it will goes to when you send a packet, it will goes to all the devices. That's the multicast. And
Right. So have you ever worked on multicast?
No, but only theory I have known all these days, but I haven't get an opportunity to work on multicasting. Only PIM and IGMP theory part I was able to grasp things like sending multicast traffic is nothing but sending a single host to many, or with the help of one RP, so that which request take the request of the joiner and all stuff.
Right.
Okay.
So if we will talk about multicast, as you people are saying, if there is a server, there are a couple of clients, we could have very first Unicast, which is one-to-one thing. Like this server can communicate with any one of them. Unicast traffic. Everybody of us are aware that what is unicast traffic. Class ABC is allocated for your IP schema. Then we can have a broadcast traffic. Broadcast traffic is for when one is sending to the all. Like this is sending to the all of the broadcast. Okay. So 255, 255, 255, 255 is your layer 3 broadcast, or FFFFF, your layer 2. Then if we will talk about multicast, the range starts from 234 to 239. If your first octet is belonging with this IP address, it means it is multicast. 224 to 238 is the public range. Similarly, within your organization, if you wanted to use multicast address, you can start with 239. We can say, okay. So
Okay.
what is multicast? Multicast is nothing, but if I will talk about multicast, it is one to a group. Okay. Or I can say, as Shashank was saying, many. Maybe these two guys are the part of group. So multicast means that same multicast stream will be broadcasted, or sorry, will be streaming to these two devices, not to this third one. That is your multicast. And if I will talk about the prerequisite, of multicast, then one thing you should be aware, for making the multicast work, your unicast routing should be proper first. Unicast routing, either you are running OSPF, EIGRP, whatever, okay, that should be very much proper. And then after your unicast routing, your IGMP, your PIM, these kind of things will come into the picture.
Sparse.
Okay. stream dense mode, sparse mode, what are the mode are, maybe we will cover that later on.
Okay.
But these things are important. But before going ahead, I would like to ask a question. Okay. I would like to see that, okay, what is our understanding about the multicast? Okay. So let me ask a question. So let us say I have, maybe here I am defining about what kind of packet or traffic is coming. Here I am defining about source IP. Here I am defining about destination IP. Here I am talking about source map. Here I am talking about destination. So let me tell, when a packet is a unicast, okay, and there is a server probably which is a source, that is 10.1.1.1, okay, and probably there are some clients also. Let me just describe some clients. These clients can be any IP, probably let me take the same range, 10.1.1.2, 10.1.1.3. In case of unicast, source IP would be what? 10.1.1.1. Destination, if I am saying that third client is there, so destination would be what? Destination would be 10.1.1.3. Let us say server MAC is AA, this MAC is CC, this MAC is BB. What will be the source MAC? A.
AA.
What will be the destination MAC?
CC.
Eventually it will go to the CC, but there is a separate story about the MAC, because MAC keep on changing in each every segment, but it's all right. Let me just, for the simplicity sake, I am saying CC. Okay. Now, next part, if my broadcast packet is coming, what will be the source IP? 10.1.1.1. What would be my broadcast IP? As I was telling, all 255. Source MAC, destination MAC, all FF, as I was telling you, right? Now the main thing comes for, what if I have a multicast? And let us say these two both hosts are joining a group 239.1.1.1. Can anybody let me know what would be my source IP? Any guess? What could be my source IP?
Source IP would be that only. 10.1.1.
Source IP will be 10.1.1.1 only.
Yes.
Perfect. What would be the destination IP? This will be the multicast group 239.1.1.1.
Okay.
What is source MAC? AA. What is destination?
Where this the group IP will be there, destination MAC will be there.
How? Group IP will be defined on both of the clients. So which destination MAC will be in use? Any maybe suggestions? Okay, let me tell you. Whenever such thing happen in the multicast, the MAC will get derived by a formula. Okay, it will be get derived by a formula. In beginning, it will be 0, 1, 0, 0, 5. These bits are reserved. These are 24 bits. Yeah, 24 bits reserved. The next 24 bits will be derived from the multicast group. Total MAC address is having how many bits? 480 bits. 48 bits. So 48 bits.
Yeah.
So 24 bit I am saying 01005B. Next 24 bits are getting derived from multicast group.
Multicast
Our
group.
group is 239 1.1.1. If I will be gonna cover this, like convert this in the hexadecimal, 239 will be approximately 001. It will be 0000001 and 0000001. This is the conversion. The 24th bit or the last bit will be converted into 0 explicitly. Okay, it will be get converted to 0, whatever bit it is, either it is 1 or either it is 0, it will be get converted into 0. Now if you will see, this is 0 1, this is 0 1, this is 0 1. What will be the MAC? 0 1 0 1. Or 0 1 0 0 5E 0 1 0 1 0 1, whatever representation you wanted to understand. This will be your MAC address. If you notice ever about the OSPF that is running out to 24005, again there would be a MAC. The MAC will be in starting, it will be 01 00 5E, and in the last it would be 000005. Your OSPF MAC. So every multicast group will have layer 2 address get derived from this formula. Any question?
But after the first 24 bits which are fixed, the next 24 bits, the first one will get converted to 0.
Only the first bit.
Okay, so that is the 25th bit. 25th bit.
24th.
Okay. Okay. If you calculate from the right side. Okay. Okay. So the first 224 to 238 are the fixed addresses for the multiple.
Yes.
Okay.
These are the fixed. Probably I will open the Wireshark and I will show you in the lab.
And whatever assigning to the host or any group, the addressing starts with 239, is it?
As I told you, it will be starting from 224 to 239. Okay, but the private range is
239. Okay. Till 238, it is public. Okay.
Okay. Now, let me discuss a couple of the scenarios with you guys. Probably your understanding would be much better there. Okay, for the multicast. Let us say if there is a single broadcast domain. If there is a single broadcast domain, okay, we have already discussed about something named as BUM. Can anybody let me know what is that? Broadcast
Unicast,
unknown, unicast, and
multicast.
Unknown unicast, not unicast. If such traffic will come, it will be get flooded. It will be get flooded on every port. I am talking about tier 2 domain. right?
Yeah.
It means multicast will also get flooded on every. So if there is a switch and we have couple of the hosts that are, connected over it. If multicast traffic arrive, it will get hit to each and every port without any condition. Let us say that one of these hosts don't want to have the multicast traffic. But since it is a multicast traffic, it will be get flooded on every port. For the same, we will learn about something known as Igmp snooping. That is optimization technique. This optimization technique will say that, okay, if the host does not require it or there is no requirement from the host, do not send the traffic over. Cisco earlier use was CCNP, but it's out of date now, no more in use. This is your single broadcast domain. Okay. Let me just ask, if we have one device in between, let us say this is the server. This server connected with the router, and router have the LAN area, and on this LAN area there are some of the clients. What happened now? If it is a unicast, what we required is, because there are two segments, we require the unicast routing.
Yes. Different subnets routing.
If there are different subnets, we require a unicast routing, but because it is the same, connected on the same device, probably we don't require. Okay. So in this, not in this case, maybe I will discuss that case later on. I will build one more router in between. So if such is the case, okay, and we need to tell that, okay, there are some clients that are listening to the group 239.1.1.1. So we need to make this device also aware about Igmp. This device should be aware about Igmp. When router will get this traffic by default, router will drop this traffic by default, will drop any of the broadcast or multicast traffic. Until or unless we are defining Igmp configuration on the device. I will show you in the lab, don't worry. Are you getting this point?
Okay.
Last scenario, what I was discussing is, let us say we have a server connected to a router, then another router, then probably there is a LAN. The devices are connected over there. How the communication now happens? The prerequisite is unicast routing should be there first, properly. Unicast routing should be proper. One thing, very important. Second thing, we required end-to-end multicast routing.
Yes.
And the preferred protocol is PIM. As you were saying, PIM can have again two modes. It can have the dense mode, it can have the sparse mode. This guy should be aware about Igmp and multicast routing. This guy should be aware about Igmp and multicast routing. Once this part is clear, the multicast traffic can stream from there to these end devices. And on this switch, we can have Igmp snooping so that the hosts which don't want to listen to this traffic switch should not forward that traffic over there. Any question, guys?
Can you repeat the last part? I didn't get it.
I was talking about IGMP snooping. That if we are applying the IGMP snooping, as I was describing you, that IGMP snooping is the way that if some hosts don't want to listen to the multicast traffic, IGMP snooping will take care about that. That okay, we should not forward this traffic to that particular host or that particular port.
Okay. Okay.
That was your basics of multicast. Let us now talk about IGMP joining process. Can anybody let me know what is the IGMP joining process?
You can explain it.
Okay, it's okay. Let me just explain. Let us say we have a device. There is a switch connected. There are a couple of hosts connected over there. This is a very simple topology. Okay. And let us configure the router IGMP on the router first. So I created IGMP on the router. What I need to do? First thing, I need to enable multicast routing. I need to say that, okay, you are IGMP aware. Once this part is done, switch will gonna send a query. In every 10 seconds. And we'll ask if anybody is interested to join this or not. Okay. It will be sourced from your particular source IP. Destination to 224.0.0.1 to all of the devices. And it will keep on checking the same thing within every 10 seconds. IGMP is not enabled on the router. You need to enable it. Sorry, go ahead.
Okay. Just like hello packets, sending it to that 224.0.0.1.
Mm-hmm.
Is it similar kind of process?
Maybe you can, yes.
Okay.
Let us say after some time, this guy is asking for multicast. When it will ask for a multicast, it will get triggered for the multicast. This process is known as membership report. So a membership report is generated for whatever group it is asking for. Let us say it is asking for 239.1.1.1. Getting this point?
Yeah, yeah.
and the IGMP query. This is maximum response time. Maybe the query time is 60 seconds if I'm not wrong. It is 60 seconds. Okay. 60 seconds is your query time, which can be reduced. Every 60 seconds, it will send the query. Okay. So when it will have that membership report, the multicast group will be get formed. Probably let me share my lab over here and show you the same process. Give me a minute. Okay. Can you check it?
Yeah.
Maybe give me a minute. Okay. Let me share here.
iOS server desktop connected to switch.
Let it get booted up. As per our communication, first, we will be making configuration on the server. First thing is what? First thing is your unicast routing should be there. So every device should be have the IP address. It can be of any range, 10 range, 20 range, whatever range you have. Okay, and every device should get communicated with each other. That is the first requirement. Second thing, we need to enable the IGMP over or multicast routing over our router. This is router, which is acting as a server. This is going through the switch, and this request will go to the ultimately to the client. But client is not listening correctly. Currently, nothing will be there. This will keep on sending the queries. But when client will ask for the data, it will be a triggered thing named as membership report, and there would be a group get formed between these two devices that we need to check. Okay. Now, let me just log into probably version 1, switch, and VIOS 2 that is acting as a client. VIOS 1, it is getting booted up. Let it get boot up, take some time. Okay. Then VIOS 2, where is my switch? There should not be any configuration on the switch. Nothing. There is nothing on the switch currently. Everything is in the basic VLAN 1. Okay. So no configuration on the switch. I am closing the switch side. I just opened it just to show you. Now, if I will check over here, version 1, show VIOS 1. If I will check, there is a IP 10.1.1.1 range. Over here, it should be 10.1.1.2. Yes. Let me just ping my own IP, pingable, and another side, the server side IP, pingable. So my unicast traffic should be okay. There should not be any problem with the unicast traffic. Before doing anything, let me start capture. I just wanted to show you, okay, how these things will work. I just start captured. You can see there would be a lot of things, but I am just interested in IGMP. Probably there is nothing on the IGMP because by default, none of the things are enabled on the IGMP. Let me go on the VIS router 1, show you, show IP IGMP interface. You can see that by default, there is nothing. What I can do is, I can go to the config T. Here, I can put the command IP multicast routing, it was, yeah. IP multicast routing, okay. And then whatever interface I am interested for, probably let me check which interface, 0 by 0. I need to say, okay, IP PIM but PIM is passive currently. That is a way to, just generate. And let me debug IP PIM. I'm just debugging it also, and let me see if some traffic is there. And are you able to see that? What I was talking about is membership query. As I enabled it, it is sending over the Igmp, Internet Group Management Protocol. Over the Igmp, it is sending a membership query. This is a general query. So general query is sent. And this general query has a multicast address, is currently not defined, but for all of the address. You could see over here, it is destined to 224.0.0.1. Okay, so that is how it is sending this alert to every router. The membership query. It will be get sent probably in each 60 seconds. Okay, we can match the time. Okay, if you will check it, you will find out it's probably 60 seconds that it will be get sent in every 60 seconds. Same you can see into our device also. Okay, I need to debug IP, Igmp, and probably let me just keep it. So every 60 seconds it will be get, sending this kind of statistics. So that is one thing. Membership query is sent. I can make changes into this query timer, probably a little bit smaller one. Interface give 0/0, IP Igmp, IP Igmp, and query interval to the 30 seconds. Just I am reducing the timer so that it can be seen, quickly.
Default is 60 seconds.
Before 60 seconds, let me show you. So, like if I will check the show IP Igmp interface whatever. Oh, show IP Igmp interface. You could see this, that now it is configured with 30 seconds. Version is 2. Internet address is 114. Which interface? Gig 0/0. Rest all of the things probably we will check in coming session, but that is how. So you can see this query is sent. Okay. Every 30 seconds, this query will get sent. Probably same thing you can monitor over there in the Wireshark. Same thing. Okay, you see, every 30 seconds it is now going. So 204, 234, every 30 seconds. Okay, so it will be gonna set. You could see over here also 615, then 54, and then 615, 616, 24, probably again 30 seconds. So every 30 seconds, a general query is getting sent for the version 2. So that is what I was saying. Now, let us say after some time, a client is triggering the request that, okay, I want to join. Let me go to the client, go to the config key. What is the way? I am going to the gig 0/0. Here I am saying IP, Igmp, group. So maybe join group. Join group 239.1.1.1. I want to join where? I want to join on 239.1.1.1. Currently, there is nothing. You can see everything is the query. But when I enter this command, you could see a lot of other details. Let me just hit enter. And can you see membership report group? So this is triggered request and it is sent by whom? 1112. What is the destination? Destination is 239.1.1.1. It is asking for the like request that, okay, I want to get it. Still the query will be keep on sending. Reason being there could be more clients. So query will be keep on sending. And you can see that, okay, receive a report from 10.1.1.2 for 239.1.1.1. Can you see? And everything is gonna build and a group is get joined. If I will see show IP Igmp join group or group, you could see that I have a 239.1.1.1 on gig 0/0, and the last report is 10.1.1.2.